Today we are going to discuss some of the problems on properties of the system and block diagram representation. First problem, find the overall operator of a system whose output signal y of n is given by y of n is equal to 1 by 3 into x of n plus x of n minus 1 plus x of n minus 2 and also draw the block diagram representation. Solution for this, it is given y of n is equal to 1 by 3 into x of n plus x of n minus 1 plus x of n minus 2. Then we can write h of s is equal to 1 by 3 into 1 plus s square. Then we can draw the block diagram representation as, this is the input x of n. So first one is 1, second one is x of n minus 1, third one is x of n minus 2. Then we have to combine all the three. We have to add it. We have to write the summation symbol that should be multiplied by the multiplier 1 by 3, which will give the output y of n. This is parallel form representation. We can write using cascade form also. That is, x of n is the input, then x of n minus 1, s square, here also I have missed, it should be s square, x of n minus 2, all the three should combine. I have to put one summation. I have to combine all the three. That should be multiplied by 1 by 3, which will give the output y of n. Next problem, find the overall operator h of a system and draw the block diagram representation. Y of n is equal to 1 by 3 into x of n plus 1 plus x of n plus x of n minus 1. Then h is equal to 1 by 3 into s inverse plus 1 plus s I can draw the system in parallel and cascade connection. So this is x of n. This is 1, S inverse, this is S. I have to combine all the three, I have to put one summation. That should be multiplied by 1 by 3, which will give the output y of n. Similarly, parallel representation, this is x of n, S inverse, that is x of n plus 1, S, x of n minus 1. I have to combine all the three. Then I have to multiply it by 1 by 3, which will give output y of n. Next, we are going to solve some problems on properties of systems. First one is linearity. Check whether the given system is linear or not. First problem, y of t is equal to 2 into d into x of t divided by dt. Let x of t is equal to x1 of t, then x of t is equal to x2 of t, then output y of t is equal to, or y1 of t is equal to 2 into dx1 of t divided by dt. Similarly, here output y2 of t is equal to 2 into dx2 of t divided by dt. Then once again x of t is equal to x3 of t and y3 of t is equal to output a x1 of t plus b into x2 of t. Then y3 of t is equal to 2 into dx3 of t divided by dt, which is equal to 2 into d by dt of a into x1 of t plus b into x2 of t, or y3 of t is equal to 2 into a into dx1 of t divided by dt plus 2 into b into dx2 of t divided by dt, or y3 of t is equal to a into y1 of t plus b into y2 of t. Therefore, the system is linear system. Next problem, we have to check whether the given system is linear or not. Y of t is equal to log of x of t. Let input x of t is equal to x1 of t, then output y1 of t is equal to log of x1 of t. Similarly, input x of t is equal to x2 of t, then output y2 of t is equal to log x2 of t. Let input x of t is equal to x3 of t, which is equal to a into x1 of t plus b into x2 of t, then output y3 of t is equal to log x3 of t, which is equal to log of a into x1 of t plus b into x2 of t, which is not equal to a into log of x1 of t plus b into log of x2 of t. Therefore, the system is non-linear. Next problem, y of n is equal to x of n square. Let input x of n is equal to x1 of n, then output y1 of n is equal to x1 of n square. X of n is equal to x2 of n, then y2 of n is equal to x2 of n square. Then x of n is equal to x3 of n, which is equal to a into x1 of n square plus b into x2 of n square. Then the output y3 of n is equal to x3 of n square, which is equal to a into x1 of n square plus b into x2 of n square, which is equal to a into x1 of n square plus b into x2 of n square, or a into y1 of n plus b into y2 of n. Hence, the system is linear. Next property, time invariant. Check whether the given system y of t is equal to x of t into cos omega naught of t is time variant or time invariant. Let input x of t is equal to x1 of t, then output y1 of t is equal to x1 of t into cos omega naught of t. Then we have to shift the output by t naught nx, then y1 of t minus t naught is equal to x1 of t minus t naught into cos of omega naught into t minus t naught. Let input x of t is equal to x2 of t, then y2 of t is equal to x2 of t into cos omega naught of t, and x2 of t is equal to x1 of t minus t naught. Therefore, y2 of t is equal to x1 of t minus t naught into cos of omega naught t. That is, y2 of t is not equal to y1 of t. Therefore, the system is time variant. Next problem, y of t is equal to log of x of t. Let input x of t is equal to x1 of t, then output y1 of t is equal to log of x1 of t. Then we have to shift it by t in x. Then y1 of t minus t naught is equal to log of x1 of t minus t naught. Let input x of t is equal to x2 of t, which is equal to x1 of t minus t naught. Then output y2 of t is equal to log of x2 of t. Therefore, y2 of t is equal to log of x1 of t minus t naught. y2 of t is equal to y1 of t minus t naught. Therefore, the system is time invariant. Next property, memory or memoryless. First problem, y of t is equal to x of t square. Then we have to vary the value of t. Y of 0 is equal to x of 0, y of 1 is equal to x of 1, y of 2 is equal to x of 4, and if I take y of minus 1, I will get x of 1. That is the future value. That means output depends on the future value of the input. Then the system has memory. Next problem, y of t is equal to x square of t. Then varying the value of t, will get y of 0 is equal to x square of 0, y of 1 is equal to x square of 1, y of 2 is equal to x square of 2, y of minus 1 is equal to x square of minus 1. Therefore, the input values depends on present value. Hence, the given system is memoryless. Next, y of n is equal to x of minus n. Then changing the value of n, will get y of 0 is equal to x of 0, y of 1 is equal to x of minus 1. That is, output depends on past values. Hence, the system has memory. Next property, we have causality. Check whether the given system is causal or non-causal. First one, y of t is equal to x of t plus x of t minus 1. that is x of t is present value, x of t minus 1 is the past value of the input, hence the system is causal. Next problem, log x of t is equal to y of t. Log x of t is the present value of the input, hence the given system is causal. Next problem, y of n is equal to x of 2n. Then y of 1 is equal to x of 2. Since output is depends on future value of the input, hence the system is non-causal. Next problem, y of n is equal to x of minus n. Then y of minus 1 is equal to x of 1. Since output depends on the future value of the system, then the system is